This question is minimum cost to convert a string 1. So you are given a 0 index string source and the target, both of length n, consisting of the lowercase English letters A, B, C, D, A, C, B, E. Now you are given the two 0 index character array, original and changed, okay, and an integer array cost, where cost I represent the cost of changing the character from original to the changed one. So you start with the string source. In one operation you can pick a character x from the string and change it into character y at a cost of z. So we have to return the minimum cost to convert the string from source to the target using any number of operations. If it is impossible to convert, we have to simply return -1. Okay, so here we have to create the link, like suppose A to B, B to C. That's where we can get the shortest path. So we will try to create the graph of the strings, and we will use Floyd Warshall algorithm to calculate the path from each node to every node. So what's the Floyd Warshall algorithm? Suppose you want to go from A to C, but you want to go from first A to B, then B to C. Like first you will go from A to B, and then you will go from B to C. So in this type of cases, we use Floyd Warshall algorithm. We go to each node from every node, and that's how we calculate this Floyd Warshall algorithm. So first let's try to code this. So let's first take the infinity value. Let's import math for that. Import math. Let's calculate the infinity value. So infinity is equal to math dot infinity. And now in the question we have been given there are only lowercase alphabets, so there are total 26 alphabets. So we can create the node, we can take those alphabets at each node. So we have total 26 nodes. So alpha is equal to 26. Now we can create a distance matrix. So distance is equal to, we will create a 2D distance matrix. That's what is needed in this Floyd Warshall algorithm. So infinity for I in range alpha, for I in range alpha. Yeah. Now the distance of a character A from itself, from the character A, is 0. So we will mark that as 0. So for I in range alpha, distance of I from I is equal to 0. Now we will mark these distances, and this cost, like A to B is given 2, B to C is given 5. We will mark this thing. So simply go for original comma change comma weight in zip of original comma changed comma cost. First we will convert this character into a node. So U is equal to ORD of O minus ORD of A. Similarly, V is equal to ORD of C minus ORD of A. Now we will simply update the distance. Distance of U to V is equal to minimum of distance of U to V comma the given cost at that particular thing. Yeah. Now we will create this Floyd Warshall algorithm. So simply for node in range alpha, this node is nothing but we will traverse each path from this node. Okay, so for node in range alpha, for I in range alpha, for J in range alpha, distance at IJ is equal to minimum of distance at IJ, comma how I told you we calculate this path, like first we will go from distance I to that particular node, then we will go from distance of that node to the destination. In this way we calculate the Floyd Warshall algorithm. Now simply we can take out what will be the total cost from source to target. So total cost is equal to 0 for original comma, or you can say for source comma target and zip of source comma target. Now we have to convert this source to target. So suppose if source is equal to target, means you have to do nothing, simply continue, else you will have to again calculate the node, change string to a node. So ord of s minus ord of a. Similarly rv will become ord of target minus ord of a. Now if distance at u and v is still equal to infinity, that means we can't trace that particular path, and we will simply return -1. Distance of u and v is infinity, else what we will return, we will return, simply we will add total cost plus is equal to distance, shortest distance from u to v, and finally we will return this total cost. So I think our code is complete. Now try to run this test cases. Yeah, so our test cases has passed successfully. Let's try to run this, submit this. Yeah, so our code passed successfully. Thank you for watching.